Good morning, everyone. So last time we have seen pressure and a thrust. Now today we are going to see the sums related to the pressure, and for that we need the equation of pressure. What is the equation of pressure? The pressure is equal to thrust by area, in which the thrust is the perpendicular force applied by the object. So thrust as a taken is perpendicular force, right? So at here we are using a force and the area for finding a pressure. So there is one question is given to you. Example number 10.6. One block of a wood is put on a table. The mass of a block is 5 kg and the volume is 40 cm into 20 cm into 10 cm. Number 1. When the 20 cm into 10 cm, and the number 2, when the 40 cm into 20 cm area is put on the table, which is in a contact with the table, what will be the pressure applied by a box? So at here, there is a box which has some volume. The box is a cuboid, right? So one of the side is a rectangle and the two sides are a square and another 4 sides are the rectangle, as shown in a figure. You can see on page number 139, right? There is a box is given to you. First of all, you have to put a 20 cm, 10 cm in a first figure like that, right? And the another one is the 40 cm, 20 cm, which is in a second figure. You have to put a boxes like that. If you put a box perpendicular, then the smaller area will be on the table, so pressure will be less. And if you put a boxes parallel to the table, during that time the higher area is in a contact with table, so the pressure will be less. Understand? So at here there is also proved that if area is higher, the pressure is less. Right? So we are calculating a pressure for both the situation. Right? So at here, first of all, what is given to you? It's example 10.6. First of all, the mass is given to you, which is 5 kg. Right? The volume is given to you, which is 40 cm into 20 cm into 10 cm. Right? Now, as you know that for finding a pressure is equal to force by area. So you have to find out the area and the force. Area can be easily found out by it, because in this example the areas are given to you as A and a B. Like as A, right? In A, what is the area? The area is equal to 20 cm into 10 cm, which gives you a 200 cm square. But as you know that centimeter square, right? You have to take it as a meter square. So 200. As you know that the 1 meter is equal to 100 centimeter. So if you want to convert from centimeter to meter, you have to divide by 100. But there is a centimeter square, so you have to divide twice. So these zeros are cancelled out and you get 0.02 meter square. Now you have to find out the pressure. Pressure is equal to F by A. But for that you need a F, force. As you know that if one of the person is just lie down on you, during that time you feels a pressure of that object or that person because of the gravitational force applied on that object. So generally the weight of an object is also one type of force which is considered for the pressure. Right? Generally you feel some pressure when you are trying to put a heavy box. During the time box is not applying any force, but this force is the weight of that box. Right? So if you want to find out this force, then this force is a weight, which is m into g, while the m is 5 and g is If that is not given to you, you have to take a 9.8. So it's a 5 into 98 divided by 10. So 5 2s and 49. So it's a 49 Newton. Now put the value. So you get 49 divided by 0.02. So it's a 49 into 100 divided by 2. 50 to 100. So at 3. 9 5 45. 4 5 4 20. 2450 Pascal. So P is a 2450 Pascal. Like that. You need to find out for the B. For that the area is 40 centimeter into 20 centimeter. So it gives you a 800 centimeter square. That you have to convert it into meter. So divide by 100 2 times. Zeros are cancelled out. 0.08 meter square. Now we have to find out the pressure. The weight is same for both the conditions, right? So weight is 49 is 0.08. So it's a 49 into 100 divided by 8. 4 2s are 8. 25 4s are 100. Now 49 into 25. 49 into 20 0. 9 2s are 18. 8 and 9. 9 5s are 45. 20. 4 it's a 5. 8 4 12 and 11. It's a 12 2 5 divided by 2. Now division. Right? 6 2s are 12. 2 1s are 2. 2 2s are 4. 5 2s. So P is equal to 612.5 Pascal. So at here, the area is less, pressure is higher. Area is higher, pressure is less. So like that, you can easily find out the pressure. Just see for sometimes. Okay, now, our next topic is buoyancy. But for that, you need to know about the pressure of fluid. What is the pressure in fluid? Generally, you know that what is the fluid? The thing which can easily, what we can say like a current, right? Which is moved easily, it is known as fluid, like air and water. Fluids are air and water. Because they can easily move from one point to the another position, right? They can float, right? So we can say that both are a fluid. And generally you know that both apply a pressure on the wall of a vessel. Like if here it is one vessel in which the water is filled. Then this water apply a force on this wall. All the walls. It applies a force on all the walls. As you know that during a Holi, we are using a balloons in which we are filling some of the water inside of it. During that time also, it just blows because of the pressure of water, which is also known as the pressure in a fluid. Due to this fluid, there is some pressure is applied on it, and which gives you another thing, idea of the another thing, a physical thing, which is the buoyancy. Buoyancy is a one type of force which is applied by a fluid on a upward direction. Generally, whenever empty water right? Whenever you push the empty bottle inside of the water, right? Whenever you pushing it, it just goes inside of it. But when you remove that pressure, it just comes in an upward direction. By which force it comes in an upward direction? It comes because of the buoyancy force applied by the fluid. So every fluid applies a force in an upward direction, and this type of characteristics is known as the buoyancy, and this force is known as the buoyancy force. So buoyancy force is generally occurs in a fluid. Whenever you pulling a water from the well during that time, also whenever your vessel is inside of the water during that time, it is lighter for you. But when it comes out of the water, it becomes heavier as compared to the when it is in a water. What is the reason behind it? When it is in a water, you are pulling it, and also the fluids apply a force in an upward direction. So there is a two forces, the force of yours and the force of water, right, which is applied in upward direction. So it helps you to pulling outside of it. But when it comes outside of it, there is no force of fluid, right? So you can see it here. Always all the fluids apply a force in an upward direction, and this type of characteristics is known as buoyancy. Well, the another one, the force which is applied by it is known as buoyancy force. Sometimes iron nails and something heavy objects are just sink inside of it. During that time also the buoyancy force is applied on it, but the value of a gravitational force on that object is higher than the buoyancy force, and just because of that they sink inside of it. One another quantity is also related to why it is sinking or why it is floating, but it will be seen in the next lecture, right? But now just you have to take attention on the buoyancy force, that the buoyancy force is the force which is applied by fluid on an upward direction, right? So today's our topic, which is sums related to pressure and the pressure in a fluid, and the buoyancy force is now completed here, right? The another things like Archimedes principle, which is work on the buoyancy force, the uses of the Archimedes principle and the relative quantities, right? We will see in the next lecture. Thank you.